Hello, welcome to another example. We're looking at finding or determining inverses in this example. Boop. Uh, just a reminder, functions that have inverses are supposed to be one-to-one. If they're not, we'll talk about that in the future. And then the inverse that you have determined has to be one-to-one as well. And we'll talk about that in this video. There we go. So, step one, this is another one of those things where I've given you step-by-step things, and it's always intended to help you get more points. Typically, students ignore step four, and as I've explained in class, I often have to go by a rubric, and the rubric says, step four, yes or no. You don't do it, you don't get the points. How many points do you think it's worth? 4 steps? 25%? I don't know. Could be. That's a significant chunk. Now, in finding or determining what the inverse is, there are kind of two basic ways of doing it. I'm doing one way. I like it this way. You can do it the other way as long as correct is correct. I'm okay with it. But this is just the way that I prefer. So, replace the x and the y. So f of x becomes the y equals, and then for this step one, we change that to x, and the original x variable, we change it to y, as seen, illustrated right there on the screen. Solve for y. And that's partially why I like this method is, anyways, we always like equations, y equals, and then the x is the input variable. I don't like equations where y is input and x is output. My brain gets confused. So that's why I choose this method. Again, personal preference, like that. Now, look at what you got at the end. That's a quadratic. Are quadratics one-to-one? No, they're not. We talked about that before. So we have to do something to make it one-to-one, like that. So what I suggest as a part of the step three, I don't have it right there with my chart there, is we're going to look at how the domain and range of our original function change into the domain and range of the inverse function. And that's going to help us figure out how to make the quadratic one-to-one, like that. So we have the original function is a square root. We have dealt with that in previous lessons. Oh, there's step three. So x plus 1 greater than 0, x has got to be greater than -1. And the relationship with the inverse, boop, is automatically the range of the inverse. Now, if you look at our quadratic that we determined is supposed to be the inverse, and you recall the parent function and the transformations, you see that -1 on the outside is a shift down, which confirms the range of the inverse starting at -1. Awesome. All right, back to the original function. What is its range? And I'm again thinking of parent function, square root, transformation shifted up. I'm going to cough, pardon me, 2 spaces. And the range starts at 2 and goes up. And that's automatically the domain of the inverse, which is what we're going to use to restrict the domain of that equation we have at the end there. Step 4. Okay, back. Step 4 is, as you see on the screen there, we have to write the answer using the inverse notation, function notation, and include that domain restriction that we determined on the grid in step 3, so that we're presenting a quadratic, but only as a one-to-one, like that. Next one.